C1 Quadratics Example 5. We say we have a quadratic equation. It already equals 0, so we need to start by getting on with factorising this. The fact we have a number in front of the x squared, where here the coefficient of x squared is 2, that makes factorising a bit trickier. Now with the numbers being small, you might be able to just spot the correct factorisation, and then you can always then check it to see if it works. Just for this video, I'm going to use something called the partition method. And here it is. We start by looking at the coefficient of x squared and the constant term. So it's 2 and 3. Multiply them together and you get 6. I'm now going to search for two numbers which multiply to give 6, but add to give the coefficient of x, which is 5. So multiply to give 6, but add to give 5. Those two numbers are 2 and 3. Now, with those two numbers, I'm going to partition the middle term. So I'm going to rewrite the quadratic, but split the middle term. I'm going to partition it, that's where the name comes from, into 2 and 3. So plus 2x plus 3x, and leave everything else alone. So take a look at what I've written there, and just check that nothing's changed from what we started with. 2x squared is still the same. We've got here a 2x plus 3x, which is 5x. Yep, there's nothing wrong with that. And we've still got the plus 3 at the end, and it still equals 0. So importantly, we haven't changed anything. This is where, again, the name comes in, the partition method. I'm going to think of this in two parts. I'm going to factorize the left-hand side, factorize the right-hand side, and remember there's a plus in the middle. So here we go. I'm going to factorize the left-hand side. 2x squared plus 2x, common factors of 2 and x. Then we've got a plus, and now I'm going to factorise the right hand side. 3x and 3, common factor of 3. Once we've done that, you should get the same bracket twice. If you don't, then you've done something wrong. You need to go back and find what you've done wrong. But when I do get the same bracket twice, I'm one step away from having it fully factorised. Because here, effectively, we've got two terms. All that is a term, and all that is a term. And they both have something in common. They both have an x plus 1. So what I'm going to do is bring out the x plus 1 as a factor of the whole equation, and then that leaves me with 2x plus 3 in the other bracket. Now, like I said, you could have gone straight there just by looking at the question, but sometimes the numbers make things difficult, so sometimes you need to fall back on a method, and this is a good method to help you out. Now that we've factorized it, now we can solve. Solve means find x. So as always, we've got two things multiplied together. And if the answer is 0, then one of the two things themselves must have equaled 0. If it was the first thing, or the first bracket, x will be minus 1. What if it was the other bracket? If it was the other bracket, then what would x have equaled? Well, it's not going to be minus 3. That's a very common error. And it comes through making too many jumps and just not thinking. If the second bracket equals 0, so 2x plus 3 equals 0, if we do one step at a time and rearrange this, we find that x won't have equaled minus 3, it'll be minus 3 over 2, or minus 1.5. Now finally, again, we could check our answers by subbing them back into the original equation, and if you get an answer 0, then you know you've got the right values.